Today we're going to look at how to read a solubility curve. So this is table G in your reference table, and you should notice that we have temperature in degrees Celsius on the x-axis, and we know that temperature will affect the solubility of substances, as will pressure for gases. So this does state up at the top that all of these are for at standard pressure. So even though many of these are solids, some of them are gas, so we are specifying that the pressure is remaining constant and it is standard pressure. On the y-axis, we have the solubility, how many grams of solute will dissolve in specifically 100 grams of water. It has to state the mass of water because if I change the amount of water, I'm also going to change how much I can dissolve. So any number that I read off this graph is for specifically 100 grams of water. If I have twice as much water, I'll have twice as much solute that can dissolve. Now there are a lot of lines on these graphs, so it's very important to make sure that you're looking at the correct line. So let's start off looking at NH4Cl, which would be this line right here. So when we're talking about a solution of ammonium chloride, that is the only line on the graph that we care about. So if I had a solution of ammonium chloride at 90 degrees Celsius and I'm dissolving it in 100 grams of water, if I go up to that line, it says that I can dissolve a little over 70, so about 72 grams of ammonium chloride. Again, that's in 100 grams of water. If I had twice as much water, I could dissolve twice as much. That is the maximum amount that I can get to dissolve. So any point that falls on the line would be a saturated solution. I can dissolve 72 grams. If I only had 20 grams dissolved, I could still make that solution. However, that solution would be an unsaturated solution. If I had, at that temperature, 110 grams of ammonium chloride dissolved, well, that's more than I can dissolve, so that solution would be a supersaturated solution. Next, let's look at a potassium chloride solution, which would be along this line itself. Well, if I had a potassium chloride solution at 50 degrees Celsius in 100 grams of water, and I dissolved 30 grams of potassium chloride in that 100 grams of water at 50 degrees Celsius, we can see because the point is under the line, I would have an unsaturated solution. I could also ask how much more potassium chloride could I add in order to make this solution saturated? Well, it can hold 42. It has 30 in it already, so I can add 12 more in order to make it saturated. If I have a supersaturated solution, one that already has 90 grams of potassium chloride dissolved, and I do something to disturb that solution. Remember, we said a supersaturated solution has more dissolved than it can dissolve under those given conditions, which is very unstable. So all of the extra would precipitate out, but I would end with still a saturated solution. So if I have 90 grams in there and I disturb the solution so that the extra precipitates out, I have 90 grams dissolved, 42 can stay dissolved. So 48 grams would precipitate out and form a solid, and the other 42 grams would be able to stay dissolved. Let's take a look at the potassium nitrate curve. Notice this one does go off the graph, but we can assume that the trend's at least going to continue upward. It's definitely not falling down back onto the graph. So there are some that go off the graph just because the graph is too small to fit all the data. The other type of question I can ask is, I have an unsaturated solution. So at 80 degrees Celsius, I've dissolved 100 grams of potassium nitrate in 100 grams of water. that solution is unsaturated. It's below the line would be at that temperature. As I cool it down, at what temperature does solid start to precipitate out? Well, as I cool it down, that stuff is going to stay dissolved as long as it can. So it's going to stay dissolved until it crosses this line. So at this temperature, which is about maybe 59 degrees Celsius, is when I've cooled it down enough that I have a saturated solution. If I cool it down any more, solid particles are going to precipitate out because the stuff can't stay dissolved at that point. So we can use a solubility curve to figure out whether a solution is saturated on the line, supersaturated above the line, or unsaturated below the line. And from there, we can determine how much more I can dissolve, or how much will precipitate out, or even how much can I cool it down and still be able to keep all of that stuff dissolved.